So, part from when the computers evolved, okay, the basic programming language was C, C++, and Java. They used to, okay. And at that time, we didn't had any ERPs or any applications, okay, means any generic products or any applications. They simply, the companies used to gather the requirements and used to develop the applications as per the requirement. Okay, so let us say, try to understand what exactly a database is. Okay, we always, the database is uh, denoted with the cylinder. Okay, whenever you see a cylinder, you should understand that this is a database. Okay, and database is collection of schemas. Okay, and this schemas internally collection of tables. Okay, tables will have relations between each other. Okay, and any database is called as relational database management system, RDBMS. Okay, so in the initial days, the companies used to gather the business requirements. For example, if we take any hospital or any hotel industry or any manufacturing industry, they gather the requirements and analyze the requirements as per that customer, and they will suggest a database to that particular customer, and they will create tables. Okay, these tables are, they in the inside the uh, database, they will build a schema first. A schema is again collection of tables. Okay, and database is run through SQL. Okay, structured query language, and procedured structured query language. Okay, and we had different types of databases from different companies. Okay, Oracle, MySQL is the open source. Okay, and SQL Server. Okay, and DB2 is the IBM's database. Okay, and and databases, we have two types, that is normalized and the denormalized. Okay, to store the data, and but to any application. Okay, if you use, for example, any every day in your life, okay, in your computer, you use any application, it's combination of okay, graphical user interface and an API which communicates and connects to the database, and data is the one which is stored in the tables in the database. Okay, so combination of these three: graphical user interface application, programming, and database, together we can build an application. Okay, so the customer as so they used to develop requirement specific applications. So okay, in our example, we'll consider some hotel or a hospital industry, right? Okay, so let us consider if users is sitting in one place and they are accessing the GUI, okay, graphical user interface application, which is developed and installed in the systems. Okay, so whenever they perform any transaction, okay, whenever they perform any transaction from these systems, okay, with the GUI is the one which user communicates, or it's a medium where a user can communicate through. Okay, and behind the scenes, application programming interface is the one which carries a set of instructions. Okay, and so when I say instructions, these instructions are programmed. That is programming language. Here it comes Java or .NET, whatever you can consider. Okay, okay. So whenever user, and this GUI, every GUI application, for example, if you open, it's a web-based application or any desktop application, for everything you will have a event. Okay, okay. So for example, if you open a Google Mail or any browser, okay, you just log in your details, right? You will enter your username. Okay, that's a field. Okay, that field internally it is considered as event. Okay, field is one event. Okay, and after entering the details, you will have a submit button. Okay, submit is one of the events. So event, so it's this, when it comes to a GUI, it is called as event driven programming. Okay, when it comes to API, okay, application programming interface. Okay, application programming interface is the one which will establish the connection between the GUI and the database. Okay, means this is the combination of both SQL statements and programming language. So whenever user clicks on submit button, it sends the request to the corresponding databases, and in return it retrieves the data to the GUI application like this. So these databases are also called as traditional databases or transaction databases, where we will store transaction data. So here, if you see in this example, we have a table. Okay, so inside the schema, we will have a set of tables. Okay, in this
Sir, 1 second, one doubt actually, since like after we have discussed, like your voice was muted, is that?
Yeah, I have muted it. Yeah.
Oh, okay, fine.
Okay, so it's just we'll take some student table. Okay, in this student table, look, this is how the data is stored. Okay, this is one column. The very first one is the student ID. Okay, and the first name, last name, and we will also call this as master data tables also. Okay, so for now we'll just call this as a table. It's a normal table. Okay, and the very first one is the student ID. So this is the ID. This is value is always unique. Okay, with the help of this unique ID, okay, this whole row is considered as unique row. Okay, and for any table, okay, this the very first one, it is will define this as a primary key for this particular table. So in any table, this is how the data will be stored. Okay, so means initially in SQL, they first create this table. Just means the table will be empty. Okay, when the transactions are performed, then only this data will come and sit. Okay, initially whenever a school is established, so they will develop an application and they'll just give it to that, right? So whenever the new admissions come into that school, they will enter the data. Okay, and the student ID is auto generated. Okay, they will only give first name, okay, last name, and the course ID, and they'll click on the submit button. Okay, it will automatically generate this student ID, and it will insert the record into that particular table. So you clear with this table part?
Yes.
Yeah. Okay, look, here it is called as primary key. So we will define this as a primary key. Okay, so the next one, if you see student ID, And to establish the relation between the tables, okay, we will, what we will do, the course ID, that where we are getting this course ID. So another master table we have, that is course table. Okay, so in the course table, okay, we have course ID and the course name. Okay, so here in the first table we are not using any course name. So for course name we have a separate table. Okay, so and this course ID here we used it as a foreign key. Okay, this course ID is the primary key of our course table, but if you want to use this in combination with the student table, it becomes a foreign key. Okay, even this key is also auto generated. Okay, we don't create this manually, we'll only select the course. Why means in the course table, whenever a new course is introduced, we will just create in the school, they will have admin screen, right? In admin screen, whenever they introduce a new course, they will just open the form and they will create the new course. Okay, and they will create a new course, and this ID is auto generated. So and we need to have the relationship between this both the tables, right? To have that, okay, we will declare this course ID is foreign key. Okay, this primary key is becomes a foreign key for this table. You cleared that?
Yes.
Simple. Okay, compound key, composite key. I'll show you. So this much I want to show you. Primary key, foreign key. Also the in the transaction tables we will see composite key. Okay, let me see. Supplier ID, suppliers and the products is the master data tables here. Look here also you will have primary key for both the tables. This is supplier ID and the product ID. Okay, and supplier ID becomes a foreign key in the products table. To show you the transaction table. Okay, when standard. Relationships are not this one. Okay.
Yeah.
Composite key. Oh, 1 second. Actually, I missed this. composite key. In this table, if you clearly observe, customer ID, order ID, and product ID, product code, okay? And product name is the text type of data, okay? This is alphanumeric and numeric. Whenever you see alphanumeric and numeric, these are all auto-generated and these are all the ID. So these are primary keys of another table, okay? In together, okay, in the database we'll have an option to declare or define a composite key. So composite key is the combination of keys, okay? So all together we call it as a composite key. Okay. Example, look, below is an example to understand the working of composite key. Considerably A having 3 columns, okay? These are the 3 columns. Customer ID is provided to each customer who visits in the store. Okay, order ID, each order placed by the customer is given an order ID. So order table will be different, customer table will be different, okay? And this is the product code. It holds the code value. Product name and attribute, okay? Attribute of the product. So below is the table that shows the diagram for the above table. So you understood that, right? So means if you want to store, like if you only consider this, a customer ID is the primary column in this, that won't be sufficient. For any transaction table, okay, you need to have composite key. Transaction, if I get transaction data. So master table here. But you know, this rule is only followed in the relational database management system, okay? In data warehousing, it's a denormalized database. Okay, here is we have one schema here, okay? So as I told you, right, all set of tables when are and with the relations together called as schema, okay? Here the very first one is the dimension customer, okay? In data warehousing language, okay, we will also call as dimensions, okay? Customer is one dimension, product is one dimension, okay? Date is, it's a time dimension, okay? And you know, these are master data tables. And if you see in the center, that's a fact table. Fact table have sales product key as foreign key, okay? Product key. So means this is coming from the product table, okay? And sales customer key, okay? That is foreign key of customer table. Sales date key, okay? This is of the our time table, okay? Date table, okay? And it will also have its own sales ID too. Maybe in this scenario, he didn't give the sales ID. It's okay. Okay, look, sales product ID, sales ID, sale customer ID. Okay, together all these three, we can also call it as in our relational database system, composite key to store the unique values. Like for example, if you take, means this is the transaction, whenever the transaction is performed against any product, look, it need to consider the sales product ID, sales customer ID, sales quantity, sales and these are the transaction columns, okay, sales price and the sales, whatever it is total. These are auto generated, okay. So means we don't means any transaction is performed, this price it will pick it, right? Sales total, it will perform the calculation and it will insert that data in that particular column. And this is the dimension table, date dimension table. Are you following me? Means are you
Yes,
comfortable?
yes. Yeah.
Look, so this is the fact table. Always the fact table stores the transactions which are performed. Whenever any transaction is happened, the transaction goes and sits in this table. Okay, so the unique identifiers becomes all three. Means a customer can purchase a product. Okay, so product is different and a customer is different. And at what time he has purchased. So that should be unique value. Product should be a unique value. Means if I consider only product as a unique value, a product can be purchased multiple times. So we cannot maintain the uniqueness of that particular transaction if we consider only product ID. So at a time, okay, a customer purchases a product, okay, on particular time. So altogether means all these three factors cannot be same for every transaction, right? So these three IDs will help the help to identify that particular transaction as a unique value in that particular table. Are you clear with this?
Yes.
Yeah, very good. If you are still not comfortable, you don't need to go into depth, but you need to understand this concept and you need to register this in your mind. So whenever you work with reports and all, at least you will know what is happening behind the scenes. Okay.
Okay.
Okay. If you are comfortable, means I'll move further.
Yeah, please.
Huh?
Hello. I'm audible to you, sir.
Sorry.
I'm audible to you.
You're audible, but your voice is not clear. That is the problem.
Hello. Now.
Yeah, audible, but voice is not clear. It's okay. Okay. Shall I continue?
Yes. Yes.
Okay. So again, after some years, what happened is, they're using the traditional databases, I said, right, to store the transaction data. Okay, after some years, all the organizations, means like Reliance or Nestle they have accumulated huge data into their databases, but the data was of no use. Okay, and the because of the competition and the population growth and all, they need to compete with the competitors. Okay, so to do competition, they need to do analysis, but and they also have the data, but the data what they have is in the relational database management system, and relational database management system is only to write the data, not to read the data. Means in relational database management system, we will have volatile data. Okay, well, when I say volatile data, means it will store each and every tiny, I mean, so it's a very granular data we will have in the relational database management system in our traditional or transactional database. So this data is where it cannot be analyzed so easily. Okay, so out of that situation, this data warehousing is evolved. Are you clear with this point?
Yes, sir.
Okay, so before coming to data warehousing, let me explain you the ERP application. Okay, so initially they used to develop customer specific applications, like customer requirement specific applications. So later what happened, like big companies like this SAP and JD Edwards, okay, they came into the market and they have analyzed all the business requirements, not just one business requirement. Okay, they analyzed all the business requirements, like different industries, okay, hospital industry, manufacturing industry, okay, all different industries, and they have gathered all the requirements, okay, and they came up with a generic application, okay, means anybody can buy that application and they can customize as per the requirement. So initially it was an application specific to the requirement. Now they have developed a product, means if any customer just walk in and they can buy that product, and they can, with few customizations, they can implement and they can use the application. You clear with this?
Yes.
Okay, so again, when I say, then these let me draw the database. So when I say they have developed an application, okay, generic product, again, so any application to develop, first we need a database, okay, and GUI and programming, as I said, okay, but again, in this case, this is also RDBMS, okay, relational database management system. But in what way it is different, means they have different schemas here. In earlier, they only had one schema because they are developing the application to particular requirement of one client. Okay, now in this case, they have developed an application where it can be used by different clients, because they can sell this as a product. Okay, so the structure of the application will be like this. Okay, here inside you will have different, means numerous schemas, okay, and each schema is called as a module, okay, and each module they have named it according to the business functionality, okay. So okay, they have like we'll consider the SAP ECC 6, okay. SAP ECC is the enterprise resource planning product. Inside this you will have different modules like finance, okay, I'll just short form sales and distribution, okay, I'll just write plant maintenance, project systems, okay, like this. They have thousands of modules, okay, each module is one schema, and inside that schema they'll have different tables with the relations, okay. Okay, we'll go SAP ECC. The last version was 6, now it is changed to, I'll always talk about SAP because you know my experience always in SAP. Okay, SAP, and this type of applications are called as ERP. Okay, ERP means enterprise resource planning. Resource planning, and this is also called as product. Okay, and follow, and you not just SAP ECC, will have, we have more applications too. Okay, let me type that here. Okay, like SAP ECC, we have people. So you heard about, I think, PeopleSoft or Art Labs. PeopleSoft.
PeopleSoft, yeah.
Okay, PeopleSoft, Oracle Labs, these are all ERPs, okay. But means SAP was very strong in manufacturing, okay, like PeopleSoft was very strong in accounting, Ban was sound as very strong in, like they had their own strengths and they had their own market grip. Manufacturing. Okay, and you understand, you know the SAP applications, right?
I don't know.
Sorry.
I don't know.
Oh,
Hello.
okay, okay. You don't know.
I don't know.
For example, if you go to SBI, okay, whatever transaction they perform, they use this SAP applications only. Okay, so or even the SAP have banking applications too. Okay, and even this is also okay GUI. Any application if you want to access, they will have a GUI. Okay, but it's here in this scenario, it's a generic product. Okay, and it can be sold by means if this SBI bank is purchasing SAP, okay, SAP will sell the SAP product to SBI Bank, and the development company will be somebody like Infosys or some Wipro or TCS. Okay, okay. Means what they will do is they will implement this application to the SBI. So before doing that, they will gather the requirements from SBI and they will select the modules. Okay, as per SBI's requirement, maybe SBI is into completely finance, right? Okay, finance, under finance you will have accounts payables, account receivables, general ledgers and all. So this is the banking terminology. Okay, so only they will select those modules and they will only implement those modules. Means this SAP, any product, when I say product, this will have structure. Okay, and whatever we want, those modules only can be implemented as per the requirement. And this is called customization. Here it is not end-to-end development, right? So they are buying a product from SAP and this TCS or some X company, they are implementing it and they are customizing the application as per the requirement of SBI. Okay, and it's a benchmark that the customization should not be more than 20%. If it is more than 20%, this product is waste. Okay, the cost will be huge again, implementation cost. So, okay, so about ERP, you are clear, right?
Yes.
Yeah, very good. Okay, so again, after ERP, okay, again, they have accumulated again huge data, okay, and they don't know what to do with the data, and the years passed, okay, and due to the competition and due to the requirements, all the business owners, they want to grow their business. And it's a very simple thing. If you want to grow in your life, you do your analysis, right? And you look back into your life, what I have done all these days, what I have studied, right? Is how I can plan my career and all, right? And based on your education or based on your experience or based on your exposure to the things, okay, so you will see where is your strength lying and all, right? So when it comes to an organizational point of view, their strength is their data, but how to analyze the data? Okay, so at this point, this data warehousing concepts is evolved. Maybe I think some 20 years back, I think 25 years back, this data warehousing concept was evolved. Okay.
Okay.
So what they have done is they in data warehousing, what happens is, I will tell you. Okay. Again, it's a database. Okay. Database is to store the data. In SAP had developed a database called a data warehousing tool called business warehouse. Okay, it was called as SAP BW. Okay. SAP BW. So here inside BW, what happens is when a business warehouse requirement comes from the client. Okay, so the first client gives a requirement in a report manner, means I want to analyze this particular data product sales by country or by region. Okay, if you want to if you want to sell more, if you want to increase the growth of particular product, so he comes with the analysis point of view. So as a business owner, if I want to increase my product sales, first I need to know the product sales, how much sales and in which countries and in which year how much I have sold. If it is going down, how much it is going down. Like, but the clients, or they are clear with their requirement, but they don't know how to do this. Okay, so with the help of this business warehouse, okay, so means any business warehouse project starts with the report requirement. Shit, everything is gone. It's okay. Let me try once again. So now you got any idea about any understanding of for this
Yes.
business warehouse?
Yes, yes.
Yeah, that's very good. But in business warehouse, what happens is here it is not a normalized database. Okay, I'll just say ECC. Okay, here we have. I'll ECC. This is. So in the normalized database, we have detail level of data, but whereas in a business warehouse, as per the report requirement, we want the data. So means we want the data in a summarized and aggregated manner. So for any time, if you want to do analysis, for analysis, you need summarized and aggregated data. For example, if you go and look into the transactional database, you will see the granular data, right? It will store what product, when it was purchased, when the transaction was to happen, even it will store the time perfectly, means at what fraction of second this transaction is performed. So that granular data will not help to do the analysis. Okay, so that is the reason. Okay, we want only summarized and aggregated. Look, as a business owner, if I see all the data, will I understand anything?
No.
Yeah. So as a business owner, I want to see only the summarized and aggregated data, product wise, country wise, total sales, and the month wise, state wise, or city wise. Okay. So as per the report requirement, what the developers will do is, for this report requirement, what data we want, and this data where it is coming from the actual tables. Okay, they will identify the schemas and the tables and the columns, what columns they want. Okay, after identifying it, the data, they will develop here in the SAP BW, they will call it as modeling. Okay, in the modeling, they will design cubes. Okay, the cubes. Okay, here, sorry, they will, sorry, Okay, I'm just drawing a squares. Okay, these squares internally nothing but okay tables again schemas, but in BW data warehousing terminology we will call it as cubes. Okay, and
Okay.
each cube consists of different columns and different as per the requirement. Okay, as per the report requirement, and these columns are combination of different tables of the normalized database. So they first we will create a model like this. Okay, and will establish a connection between these two different databases. Okay, this connection is called remote function call. RFC. And after that, here we will have a staging area. Okay, let us say this as staging. So when I talk about SAP BW, okay, in simple words, I'll tell you the generic word for this. Okay, that is ETL. Okay, ETL means extraction, transformation, and loading. So what here we are creating a model first, and then we are establishing a remote function call, and then we are extracting the data. Okay, extracting the data to the staging area, extracting the data to the staging area from the schemas which we have here, right, to the staging area. And in this staging area, what we will do, we will perform the transformations. When I say transformation, for example, I will give you a simple example. Okay, in the transaction table we have product wise sales, right? Okay, means product, unit price, and the quantity. Okay, but unit price and quantity is very hard to do the analysis. Okay, we can't do that, right? So when it coming when the data is extracted, okay, what we will do, we want the total sale of that particular product. Okay, so we'll have one more column, okay, that is total sales. We'll write a formula. Okay, we'll just multiply the quantity and price. Okay, that value will come and sit in that particular column. So while extracting, we will implement this transformation logic. Okay, so while extracting on the fly, it will perform the calculation and it will insert that particular data in that particular column. Okay, it's just a simple example of to understand the transformation. Okay, and we will also do as part of transformations, we will clean the data. Okay, means we will merge the columns. Okay, as per our report requirement, we will only, as earlier it was the traditional application was built as per the business requirement. Okay, here we are creating a model as per the report requirement for analysis. Okay, so we don't want all the attributes of product, right? So we'll only select the required columns. So that's how this ETL logic is implemented: extraction, transformation, and loading. Okay, then we will load the data into our BW models. Are you clear, Anusha?
Yes, sir.
Yeah, very good. Okay, so after creating, then again we need to do the develop the reports. Okay, so in SAP BW, we had a tool called let me write. Okay, query designer. Okay, query designer. So with the help of this query designer is internally connected. Okay, it's all together. It's one tool. Okay, and we have a query analyzer as well. Query analyzer. It's nothing but the reporting tool. Query designer, and it was Bex Query Designer. Okay, Business Explorer. They had different names in SAP. Okay, we called it as Bex. Okay, yes, this is how we will write. Even write also they will B capital and E capital, X small. Okay, Bex Query Analyzer. It is called as SAP called as Bex. Okay, Bex Query Designer and Bex Query Analyzer. But okay, so whenever you have reporting tools, then it is called as business intelligence tools. If you don't have the reporting tool, it is not a business intelligence tool at all. Okay, but these tools were not sufficient to create the ad hoc reports and dashboards. Okay, then in later stages they have introduced more tools for it, but it didn't go well. Okay, so SAP remained as a business warehouse only. Okay, and later they have acquired business objects. Okay, SAP business objects. Okay, let me draw the business objects. Let me tell this. BO, I will just say BO, or also they called it as Bob J business objects, or Bob J enterprises business objects enterprise. Okay, okay, inside this tool again what we had is I will just say the very first one is the universe design tool. Okay, I'll just type UDT. Okay, universe design tool. So here what happens is, look here what we are doing in ETL tool, we are creating the models, extracting the data and loading the data into the tables, and these tables are internally connected. Okay, then it is a single application, this query designer internally connected. Okay, and with the query designer, okay, we used to send the requests and get the requests. The communication is like this, and with the data is displayed in the query analyzer Bex. Okay, okay, here in the UDT what we will do is, here we will use the same logic what we have used in the SAP BW tool. Okay, but the difference is that it's just a semantic layer, means only logic will be here. Okay, only logic will be here. On the fly it will fetch the data, and the one more beauty of this is this can communicate to, means this can establish the connection directly with the data warehousing database, or also the traditional database. On the fly it will get the data. Hence means SAP what they had done is, they wanted to do analysis, means the already existing clients who they want to use the power of this business objects, they cannot again they don't need to change the entire system. So using their existing models they can do the reports, analysis and all. Okay, so this UDT Universe Design Tool is the tool where we can tell as develop a semantic model and publish it to the enterprise. Where it's called as BI Launchpad. Okay, you don't need to worry about it, but to give a proper idea, I'm just telling you this. Okay, and again here we have a reporting tool that is called as Web Intelligence Tool. Okay, WebE it is called as. Okay, inside this we have a query designer again, where we can develop our query or a query panel. Okay, query panel. Okay, and this query again, this is connected to UDT. Always UDT can be connected to any database. This UDT can communicate and establish connection with any data sources. Almost any data sources. This is connected like this. Okay, and we have two more reporting tools we had in SAP Business Objects. That is withdraw. X. XLCS or a dashboard designer. Okay, and this is used to create the interactive dashboards using the visuals. And one more is the Crystal. You heard Crystal, I think. Crystal reports. Oh, actually, you're not into IT, right? So you are very new to all. Actually, that's the reason I'm all telling you, because so normally what kind of reports we will deal with is ad hoc reports. Dashboards, detailed reports. Okay, so using WebI we can develop ad hoc reports. So the mostly used ad hoc reports and dashboards. Okay, even in past 5 to 10 years back also, the all the clients or the market was comfortable with the ad hoc reports, but now these dashboards are trending. We are because of the competition and because of the quick analysis, and using dashboards, so the quick analysis can be done. So now the dashboards are trending. Okay, dashboard is nothing but a data is represented using any visual. Okay, visuals can be any kind of visuals. It can be a graph, it can be a chart. Okay, it can be a, like you have different types of visuals. Using these visuals will create a dashboard. Okay. So So now what happened is from past 4 years, this Power BI has came into picture. And to work on this, any of these tools, you need to know SQL, structured query language. That's the minimum requirement. So without knowing SQL, it's very hard to manage with these tools. At least you need to know the basics of it. Okay. Always you can Google it, but you need to understand the SQL, right? So,
Yes.
okay. And in turn, these systems are connected to the these databases are connected to the systems. Okay, I don't need to draw the systems right here again. And this SAP BO is directly installed in our system, and it will connect to the servers. So till here, are you comfortable?
Yes, sir.
Very good, super. So let me walk you through the Power BI desktop tool now.
Okay.
So till here you're comfortable right now. You know what is a traditional database, what is a ERP, and what is data warehousing.
Yes.
And why the reports are used and what types of reports are there. Right?
Yes.
Now you also understand this master data, transaction data, right? So when I talk master data, transaction data, facts, you will understand, right?
Yes.
Very good.
Master data is nothing but transaction.
No, sorry. Master data.
Traditional and transaction I have heard. Master is?
Yeah, master, it's in data warehousing terminology, we call it as master data. Okay. Okay. For example, a product table is there, right? It is called as master data. Okay. Customer table, it is called as customer master data. Okay. Sales, and whenever any transaction performed against a product and customer, these transactions are stored as facts in a transaction table. This transaction table can have any name like a sales table. Okay. Any table. So against means against any product or any customer, any transaction is performed and the transaction is stored in a table, that is called transaction data. Those are facts, those are key figures. So it is called as key figures, facts, okay, figures. These, because based on this, because we need to analyze those figures, right? So based on those figures only we can drive our business further.
Okay.
So transaction data is different, master data is different. Okay, transaction data is also called as key figures, facts. Okay, we use when you are into analytical world, you will use this terminology. When you work with traditional database, you don't use key figures, facts, master data, you don't use this terminology. So when you are into analytics, you will use all this terminology. You need to be comfortable with this terminology. Okay. Okay, then I'm just quitting the screen. You don't have any doubts in the screen, right?
Later, if I quit, I can ask, right? The next session or
yeah.
okay.